Good day, everyone. Today we are going to discuss about stoichiometry. But before we proceed to stoichiometry, let's first review about the concept of mole. Last week, we have discussed about this concept, and we said that 1 mole is actually equivalent to Avogadro's number, which is 6.02 times 10 raised to 23 particles. And when we say particles, we are referring to atoms or even molecules. We have also learned about the molar mass, and we said that for the molar mass, this is equivalent to the masses of the different elements found in the periodic table. And so, by knowing the molar mass, we can now use this as our conversion, which is 1 mole is equal to the mass of the element or the compound, or we can also say that the masses will be equivalent to 1 mole. Last week, we also have learned how to balance equations. And so, by combining our abilities to balance equations, as well as to do some simple unit conversions, like for example, we have mole to mole, we have mole to mass, we have mole to particles, we can now complete stoichiometry problems. And for stoichiometry problems, they are usually involved in mass-to-mass conversions. And so we use stoichiometry because we are actually referring to the chemical reactions that are happening. Now, chemical reactions, take note, will stop when one of the reactants is used up. Now, stoichiometry problems consists of predicting the amount of grams of the product that will be formed from a reaction. And also, we can predict the number of grams of the reactant that will be needed to produce a certain amount of product. That is, if we know the amount of reactants or if we know the amount of products. So now let's go to the first calculation, and we call this as the mole-to-mole calculation. Here is the first problem. How many moles of water can be obtained from the reaction of 4 moles of oxygen? Now, in order for us to be able to solve this problem, we first need to write the chemical equation and to balance it. And we know that in order for us to calculate or to make water, we need hydrogen and oxygen. And so we get 2 hydrogen molecules, we add it with 1 molecule of oxygen, and so we form 2 molecules of water. Now, with the given equation, and of course, with our problem, we can now solve our problem. So the first thing that we need to do is we write the given and what is asked for so that we don't get confused. So we put the given, and we have here, which is 4 moles of oxygen. And we are actually being asked for the moles of water. So now that we have written this, let's go to the solution part. As I've mentioned before, in any conversion, the first thing that we need to do is to write the given. So we write now 4 moles of oxygen. Now, for this problem, since it's a mole-to-mole conversion, we are going to use what we call as the mole ratio. Now, where do we get now the mole ratio? The mole ratio is found in the chemical equation. It is the coefficients that we have written in the balanced chemical equation. And so, we are given with oxygen. This is oxygen. And we are also given with, or we are being asked for the moles of water. So this is water. The mole ratio will now be the coefficient found before the different compounds. So for water, we have 2 here, and then for oxygen, we have 1. And so this is what we will be writing in our mole ratio. We put here mole of oxygen since we want to eliminate oxygen. And on the top or above, we put now our mole of H2O because that is what we want to obtain for our final answer. After you write which compounds are given and which compounds are to be found, let us now write their mole ratio. For the water, we put 2, and then for the oxygen, we put 1. And so this one will cancel, and this one will also cancel. And so now we get 8 moles of water. Okay, so that is how we can solve our mole-to-mole calculations. So again, do not forget to write the balanced chemical equation. After that, you put what is given, and then after that, you put the mole ratio. Where can you find the mole ratio? You can find it in the balanced chemical reaction. And now we get 8 moles of water. Let's do another problem. It says here, how many moles of NH3 can be obtained from the reaction of 8 moles of hydrogen with nitrogen? So how do we balance this again? Of course, we do the balancing of chemical reactions. So we put 3 in hydrogen, and then we put 1 in nitrogen, and then we put 2 in NH3. So again, let us first put the given and what is asked for. For the given, we have 8 moles of H2. And what is being asked for? So we are being asked for the moles of NH3, or we need to find the moles of NH3. So now that we know what is given and what do we need to find, let's now go to the solution. Okay, so let's write first what is given, and that's 8 moles of H2. Then, since we want to eliminate H2, we put that here below, moles of H2, and then above we put what is going to, or what are we going to find. So that's the moles of NH3. Okay, so again, we get the mole ratio from the balanced chemical equation. And so for NH3, we write 2. And for H2, we write 3. So this and this will cancel. And so from this calculation, we now get 5.33 moles of NH3. Okay. So again, take note, write the balanced chemical equation. After that, you write what is asked for. Then you write their mole ratio from the balanced chemical equation. And you cancel what is needed to be canceled to get your final answer. So this is again our mole-to-mole ratio, or mole-to-mole conversion. Okay, so here is another problem. We have 2NaOH. We add it with H2SO4, or that's sodium hydroxide, with H2SO4 or sulfuric acid. Will now form 2 molecules of water plus sodium sulfate. And the question is, how many moles of sodium sulfate will be formed if we start with 16 moles of sodium hydroxide? Pause the video and then try to answer it before we finally reveal the final answer. Okay, so if you are now ready to answer, your answer should be 8 moles of sodium sulfate. Let us now go to the next part. For the next part, we have what we call as the mole to mass calculations. And so if we have mole to mass calculations, we actually need to convert it twice, okay? Or we need two calculations when it comes to mole to mass calculations. So let's try this first example. What mass of hydrogen gas can be produced by reacting 6 moles of aluminum with HCl or hydrochloric acid? So again, for this problem, the first thing that we need to do is write the balanced chemical equation. And so we get 2 aluminum plus 6 HCl will form 2 aluminum chloride plus 3 H2. So since we know now our balanced chemical equation, let's first write our given. So for this problem, we are given with 6 moles of aluminum, and we need to find the mass of hydrogen gas. So how do we solve this kind of problem if we are now involved with the mass? If you remember in our calculations last week, we actually calculated for the molar mass. And so we need now the molar mass of what? Are we going to get the molar mass of aluminum or the molar mass of hydrogen? So for this problem, since we are given with we need to find the mass of hydrogen, then we need to get first the molar mass of hydrogen. So we calculate for the molar mass of hydrogen, and that will be H equals 2 atoms times 1.01 grams. That will be the mass of hydrogen found in your periodic table. So we get 2.02 grams per mole. So take note, the smaller mass, we will be using that as our conversion unit. Now let's solve for the mass of H2 that will be produced. So we have here the given, which is 6 moles of aluminum. So that's the first thing that we write. After that, since we need to eliminate mole here, then we need to write the mole ratio first. So moles of aluminum, and then we have the moles of hydrogen. So again, where can we find the moles? It's in the balanced chemical equation. So for aluminum, we have here 2. And then for hydrogen, we have here 3. Okay, so now we can cancel this and this. So we do not have aluminum anymore because we already canceled it. Now, since we need to calculate the mass, the next thing that we do is we use now the molar mass. And so we have here mole above, and so we need to put the mole of hydrogen below. So that where will we get the mole of hydrogen? Will it be from the balanced chemical equation again? No, we will get it from the molar mass, okay? So we will get it from here. So that will be 1 mole of hydrogen. And we get 2.02 grams. Now, please then don't get confused because some of the students, they always get confused. They think that if it's grams, they will put the mole ratio. Do not put the mole ratio. You have to put 1 mole because you are getting the conversion from the molar mass. So now we have the moles here above and the moles below. So we now cancel the 2 moles. And so we are now left with the mass as our final unit. And so for this problem, our answer will be 18.18 grams of H2. So this is now our final answer. Okay, so again, take note. Let's just review. We need first to write the balanced chemical equation. Next, you write what is the given. Then you write the mole ratio. And where can you find the mole ratio? It will come from the balanced chemical equation. And then after that, you multiply it to its molar mass. Okay, so that you again cancel the moles, and so your final answer will be the mass. Now let's go to the second problem. So it's actually the same chemical equation. So we have 2 aluminum plus 6 HCl will form 2 aluminum chloride plus 3 hydrogen gas. So the question is, what mass of HCl is needed to react with 6 moles of aluminum? So let's first write the given. So we have here our given, which is 6 moles of aluminum, and we have to find the mass of HCl. Okay, so as I have mentioned earlier, the first thing that we need to do is find the molar mass. And since we are going to find the mass of HCl, we need now to solve for the molar mass of HCl. So let's write molar mass. So that will be H and Cl. So for hydrogen, we only have 1. So that's 1.01 grams. For Cl, we also have 1. So that will be 35.45 grams. And so we get 36.46 grams per mole. Okay, next. So now that we know the molar mass of HCl, we can now calculate for the mass of HCl. So we write now our given, which is 6 moles of aluminum. Next. So since we are given with the moles, we need to write the mole ratio first. So we have here the mole of aluminum and the mole of HCl. So where do we find that? Again, in the balanced chemical equation. So we have 2 for aluminum. We write 2 here. And we have, for HCl, we need 6. So we write 6 here. Okay? So this and this is going to cancel. Next is we are looking for the mass of HCl. And so we now put the conversion from the molar mass. So this one can be 36.46 grams per 1 mole, or 1 mole per 36.46 grams. So obviously, since we have here a mole above, and so we need to write now moles below. Mole of HCl so that it will cancel. So what do we need to use now for our conversion unit? We need to use this one. Okay? And so what do we do now? We just write 36.46 grams. So we have here mole and mole here, that will now cancel. And so what do we get? That will be 656.28. What will be our unit? Grams of HCl. So this is now our final answer. Okay, let's review. Again, we have the given. After that, we write the mole ratio, which will come from the balanced chemical equation. And then we convert using the molar mass. And so we get now our final answer. We have 656.28 grams. Okay, so now let's go to the next problem. So we have here, it says, we have 2 sodium hydroxide. So this is sodium hydroxide plus sulfuric acid. This is H2SO4, the sulfuric acid, will now form 2 molecules of water plus sodium sulfate. So this is sodium sulfate. So the question is, how many moles of sodium sulfate will be formed if we start with 200 grams of sodium hydroxide? So for this problem, if you notice, it's actually a little bit different with um, the first two problems that we solved, it's because you are given now with the mass, but you need to get the moles. So it's the other way around. A while ago, we solved for the grams given the moles. Now it's the other way around. You're given with the grams, and you need to find the moles. So how do we solve this problem? Okay, so again, we have here our problem. Let's first write the given. So our given for this problem will be 200 grams of sodium hydroxide. So that will be sodium NaOH, sorry. So that will be NaOH. Okay. And we need to find for the moles of sodium sulfate. So that will be Na. Okay, so that will be Na2SO4. Okay, so now that we know which is our given and which is our what we need to find, what's the next thing that we need to do? Of course, we get the molar mass. What molar mass are we going to get? We will get the NaOH. So since that's the one that has grams in it, so we've put the molar mass of NaOH. And so for sodium, we only have one, so that will be 22.99 grams from your periodic table. We have for oxygen times one atom, so that's just 16 grams. And then hydrogen, we also have one atom, so that's 1.01 grams. And so we get a total of 40.0 grams per mole. Okay, next we write the given. That will be 200 grams of NaOH. We multiply it now with, what do you think are going to multiply it? Are we going to use the molar mass, or are we going to use the mole ratio? So in this case, it will be the opposite, or the other way around. Since we have here the grams, so the first thing that we need to use is the molar mass, not the mole ratio, because we need to get rid of the grams here. So what do we use for conversion? Is it 40.00 grams per mole, or is it 1 mole per 40.00 grams? So obviously, we are going to put, or we are going to use now this one. Why? It's because what is above, or what is the given, is grams. So of course, we need to put grams below so that it will cancel. So that will be 40.00 grams of NaOH. And above, we put 1 mole of NaOH. And so this one, we cancel grams, we also cancel grams. Next, we now put the mole ratio because we need to find the moles of sodium sulfate. And so we put mole of sodium hydroxide below because we need to get rid of it. And we put the mole ratio of sodium sulfate above because that is what we are looking for. And so for this problem, again, where do we get the mole ratio? We get it from the balanced chemical equation. For sodium sulfate, so we have only one. And for sodium hydroxide, we have two. Okay? So this and this will now cancel. And so for this problem, what we have is 2.5 moles of sodium sulfate. Okay, so that is now how we solve for the mole to mass calculations. So now we go to the final calculation of a stoichiometric problem. And this is now what we call as the mass-to-mass calculations. So for the mass-to-mass calculations, it will be three kinds of calculations. So let's start with this problem. How many grams of SnF2 can be produced from the reaction of 30 grams of HF with Sn? So again, we need to write the balanced chemical equation, and that will be tin plus 2 hydrogen fluoride will form tin fluoride plus hydrogen gas. Okay, so again, as I have mentioned earlier, we need to first write the given. So let's put the given. That will be 30 grams of hydrogen fluoride. And we need to find for the mass or grams of SnF2. Okay, so the next thing that we need to do is we have to put the molar masses. Now for this problem, we need to get the molar masses of the two because we have here grams of HF as well as grams of SnF2. So of course, we need to find now their molar masses. So how are we going to solve for this problem? So we get first for the SnF2, so that will be Sn and then F. Then we have also the H and, sorry. So we have also the H and F. Okay, so let's solve first for their molar masses. So for HF, we have the hydrogen, that's 1 point, okay, that's 1.01 grams. And then we just multiply to its number of atoms, that's just 1. So, and then for fluorine, we have 19.00 grams. Okay, so here we have 20. So that will be 20.01 grams per mole. Now, what about for SnF2? So we have 114, so that's 118.71 grams. And then for fluorine, again, we have 2 atoms. So we have 2 atoms of fluorine times its molar mass, which is 19 grams. Okay, then we add it together. So that's 118.71 plus 38 grams. So for SnF2, the molar mass will be 156.71 grams per mole. Okay, so take note of their different molar masses. So now let's go to the calculation of the from mass to mass. Okay, so first is we write the given. We have 30.00 grams of HF. Next, we put the molar mass of HF because we want to get rid of the grams. So again, for the conversion, since we have grams above, let's put grams of HF below. And as we have mentioned earlier, the molar mass of HF will be 20.01 grams per 1 mole of HF. Okay. Next, we put now their mole ratio because we want to get rid of the moles of HF. So by the way, this and this will cancel. So we put now their mole ratio. So again, since HF is above, we put HF below. And we are looking for the moles of SnF2, so we put it above. Now, for SnF2, we only have 1, and then for HF, we have 2. So we put 2 moles of HF, 1 mole of SnF2. So that this mole of HF will cancel with the mole of HF. Next is we now write their molar mass of SnF2 because we are again looking for the mass. Okay, and so since mole is above, we put 1 mole of SNF2, and the mass of SNF2 is 156.71 grams. And so this and this will cancel. Okay, so now what do we have? Our final answer will be 117.47, okay, 117.47 grams of SNF2. Okay, so this is now our final answer. So again, let's review. That will be 30 grams of HF. We multiply it with the molar mass of HF. Then we multiply it to the mole ratio of SNF2 and HF. Then we multiply it to the molar mass so that we can get the final answer. Next question. We have here 16 grams of H2 reacts completely with nitrogen to form NH3. How many grams of NH3 will be formed? So the balanced chemical equation is 3H2 plus N2 will form 2NH3. Okay, so how are we going to solve this problem? So again, we put the given. Okay, that will be 16 grams of H2. And then we need to find the grams of NH3. Next, we need to get now their molar masses. So we have H2, that will be 2 times 1.01 grams. So we get 2.02 grams. Whereas for NH3, okay, so nitrogen and hydrogen, we have 1 atom of nitrogen, that's times 14.01 grams. And then for hydrogen, we have 3 atoms, so that's times 1.01 grams. And so for nitrogen, we get 14.01 grams. And for hydrogen, we get 3.03 grams. Okay, and so our answer will be 17.04 grams per mole. This one is also per mole. Okay, so take note of their molar masses because we will be looking at, or we will be solving that for the this kind of calculation. Okay, next we write the given. So we have 16.0 grams of H2. Okay, next, we write the molar mass of H2 so that we get rid of H2. And so since, again, this is grams, so we need to put grams below. So grams of H2, and that will be 2.02 grams of H2. Next is per 1 mole of H2. So that this and this will cancel. Next is we put the mole ratio. So if we go back again to the equation a while ago, we are given with 3 moles of 3 molecules of H2 plus 1 molecule of N2 will form 2 molecules of NH3. Okay, so our mole ratio will be, we are looking for the moles of H2 and moles of NH3. Okay, so for NH3 we get 2, and then for H2 we get 3. So which means that this and this will cancel. Next is we need to convert it now to grams. So we use the molar mass. And so since this is mole again above, we put that here below. So mole of NH3. And we need to use the molar mass. That will be 17.04 grams of NH3 per 1 mole of NH3. So that this and this will cancel. Okay? So next, we calculate it now, and so we get 90.1 grams of NH3. Okay? Again, do not be confused with this problem. As we have mentioned earlier, this will be the molar mass of the given, okay? And then we have, okay, this will be our mole ratio, okay? And also for the last one, this is now the molar mass of what is being asked for, okay? Molar mass of what to find. So please do not get confused of these kinds of problem, especially the conversion, okay? Do not be confused with these moles here and then these moles here. Do not use the mole ratio for that. The mole ratio is only for the middle, okay? Again, where do we get the mole ratio? As we have mentioned earlier, we get it from the balanced chemical equation. So these two will go here, and then these three will go here. Okay, so I hope that that is clear. Let's now go to the last problem. Solid lithium hydroxide is used to remove carbon dioxide and is called a carbon dioxide scrubber. Now, this technique has been used for space vehicles, and the reaction for this chemical equation is 2 lithium oxide or 2 lithium hydroxide plus carbon dioxide will form Li2CO3 or lithium carbonate plus 2 water. So the question is, how many grams of carbon dioxide can be absorbed by 785 grams of lithium oxide? Okay, so let's solve for this problem. So again, we have this equation, and we are being asked for the grams of carbon dioxide if we are given with 785 grams of lithium oxide. So what does our problem mean? It means that if you have, sorry, if you have given with LiOH, how many grams will be needed to react with carbon dioxide? So how many grams of carbon dioxide needs to react with your given LiOH? So that's what it means. So by the way, why is this problem, or why are these problems very important? Because take note, in the laboratory, this is what we do. So for example, we need to produce a certain amount of um, product. So we need to solve how much reactants do we need to mix together so that we will form a product. Or let's say we are given with a reactant, like for example, for in this example, we have the LiOH. You are given with LiOH, so you need to, of course, produce Li2CO3 and water. How many grams of carbon dioxide do you need? So, of course, you cannot just put anything that you like. So you really have to mix them together. It's just like when you are baking, or let's say you want to let's say the simplest one, you want to make your own coffee. So and then you like coffee that is black, so for example, and then a little bit of sugar, and let's say a little bit of milk. So let's say what you want is like 2 tablespoons of sugar, and then 1 tablespoon of milk, and then 1 teaspoon of coffee. So of course, if that is your preferred number or tablespoon for your coffee, you cannot just put anything, okay? So you cannot put like 2 tablespoons of coffee. It will be too bitter for you. So it's the same with stoichiometric problems, okay? So let's continue to solve this problem. How many grams of carbon dioxide will be absorbed by 785 grams of lithium hydroxide? So let's first write our given. Okay, so for the given, we have 785 grams of lithium hydroxide. And for our, what do we need to find? Of course, we get grams of carbon dioxide. Okay, so next we go now to the solution. As I've mentioned earlier, the first thing that we need to do is to get their molar masses. So we have LiOH. So for Li, O, and H, they're just one atom per element. So we just put 6.94 grams plus 16 grams plus 1.01 grams. And so our answer here is 23.95 grams per mole. Next is we have for carbon dioxide. So for carbon dioxide, we have one atom of carbon and then two atoms of oxygen. So for carbon, the mass is 12.01 grams. For oxygen, it's 16.0 grams. And so we get 12.01, and this is 32 grams. So we have for carbon dioxide, that's 44.01 grams per mole. Okay, next let's solve for the problem. So we are given with 785 grams of lithium hydroxide. Again, we use the molar mass. So we have to use the molar mass, this one, in solving first or in conversion. So we have 1 mole of LiOH per 23.95 grams of LiOH. Okay, so this and this is going to cancel. Next is we get now their mole ratio. And so we put moles of LiOH below so that we can cancel it above. And the mole of carbon dioxide above. Where do we get this again? From our balanced chemical equation. So this one and this one. Okay, so for carbon dioxide, we only have 1 mole. And for the lithium hydroxide, we have 2 moles. Okay, next, we cancel this and this. And then finally, we convert it to mass. So we have the molar mass of carbon dioxide, which is 44.01 grams. And so we get 44.01 grams per 1 mole of carbon dioxide. So this and this is going to cancel. And so our final answer here is 721.25, okay, 0.25 grams of carbon dioxide. So this is now our final answer. Okay, so that's it for the calculation. I hope that you were able to solve for the mole to mole, and then we have the mole to mass, and then finally we have mass to mass calculations. Okay, so now for your practice exercise, let us solve these following problems. Okay, so please take a screenshot of the following problems. This will be your practice problems in preparation for your upcoming quiz. So please do take time to solve this practice problem. So for number 1, carbon monoxide is a poisonous gas that combines with hemoglobin in the blood, thus reducing the amount of oxygen that can be delivered to tissues. Under certain conditions, carbon monoxide is formed when ethane, that is C2H6, in natural gas is burned in the presence of oxygen. how many moles of carbon monoxide are produced from 3.55 moles of C2H6. So we have here the chemical equation, which is C2 2C2H6 plus 5O2 will form 4CO, carbon monoxide, plus 6 water. Number 2, wine is produced by the fermentation of grapes. In fermentation, the carbohydrate glucose, that's C6H12O6, is converted to ethanol, which is C2H6O, and carbon dioxide. How many grams of ethanol are produced from 5 moles of glucose? So that will be C6H12O6 will form 2 ethanol or C2H6O plus 2 carbon dioxide. The third problem will be acetylene gas, C2H2, undergoes combustion to form carbon dioxide and water when it is used in the oxyacetylene torch for welding. So the equation will be 2C2H2 plus 5O2 will form 4 carbon dioxide plus 2 molecules of H2O. First question will be, how many grams of water can form if 113 grams of acetylene is burned? And then for letter B, how many grams of acetylene will react if 1.10 moles of carbon dioxide are produced? So I hope that you find time to answer this, and I hope that you have enjoyed our lecture and that you have understood our lecture today. And I'll see you again for the next lecture. Bye, everyone.